Hi everyone, I'm Nathaniel.
Hi, I'm Sarah.
And today we're going to be talking about music, social bonding with the self-other, with that merging, as well as some neurohormonal mechanisms that fire in our brain when listening to music.
So to start out, I'll just give you guys a little bit of background information from the article. There's some pretty tricky definitions in here, so I'm just going to go over these for you. First of all, social bonding is referred to as social closeness. So this is feeling close with others, feeling as though you have a good relationship with someone else. Additionally, mimicry is referred to as similar or simultaneous movements as someone else. So for instance, if someone were to clap, mimicry would be to clap with them. And then self-other merging happens when you are watching the actions of another person and the similar or the same motor networks activate in that other person's brain, in the same region of the brain. Also, dyads are referred to as two groupings. So in music, this might be two rhythms or two notes. And finally, synchrony is simultaneous movements with rhythmically matched timing. So this is similar to mimicry, except there's a standout feature of being rhythmically matched with that action. Synchrony is especially prevalent in music-based activities, and this reveals how humans are culturally drawn toward rhythmic beats that are embedded in music. So we're sort of inept to these beats.
So what happens in our brain when we listen to music and when we do all this self-other merging, as well as some other social activities with music, but really in our brain there's a number of neurotransmitters and hormones firing throughout this process. So really one of these is oxytocin, which is known as the social neurohormone. So really it helps, or really it's fired during social bonding activities, and it leads to increased trust. Some eye contact, generosity, face memorization, as well as some other, positive social functions. And then another term is the EOS, which is known as the endogenous opioid system, which is a system in our brain that releases various neurohormones and other endorphins that really are involved with social bonding, musical activities, as well as pain and pleasure perception and thresholds. Some other things going on in our brain are cortisol, which deals with stress, cytokinin, some growth hormones, dopamine and their interactions with the EOS, making us feel good, and that sort of thing. And so really the EOS and the functions of the EOS is very similar to, let's say, like a runner's high. So when you're running and you're quite exhausted, you kind of have this nice, calming, good feeling in your body, which is really from the releasing of hormones and endorphins. So really, what's interesting about music is that rhythmic patterns found either in nature or in songs can actually help with pain reduction. So such as like being at a gym or something like that, working out, following your breathing or listening to music can oftentimes allow you to work harder and to not give up as quickly.
Yeah, so next we have a heading about synchronization and social bonding. So this goes back a lot to what I was discussing earlier with some of the different definitions will come into play here. So first of all, mimicking and following others' actions increases the feelings of social bonding and mutual desirability. So this kind of creates a positive feedback loop, which means that when we feed into others' actions or replicate those actions, they continue to be replicated. And that increases over and over again the feelings of social closeness. And also we have synchrony, and synchrony has a greater effect on social bonding than mimicry does. So you feel closer with someone else when those movements are rhythmically matched rather than when they are not. And this is present in both simple and complex rhythms in music. And we have an example here for you as well. So if a child is beating on a drum, he or she will be better able to synchronize with the beat if they're watching someone else do it, rather than if they're just listening to a loop of a drum over and over.
So with the synchronization and mimicry in our minds, we can see how it affects or how it fits into music. So really, when we listen to music and are synchronizing with other people, we have a lot of the same neural networks that are activated when we're perceiving someone else's musical movements. And so really, synchronization is a hard thing to do in especially large groups of people because it's hard to, get everyone's movements down exactly the same, perfectly. However, music, one thing that's pretty cool about music is that it creates a scaffolding and a foundation for this mass or this large synchronization between people. So what's cool about that is that a lot of these group musical activities, especially ones with non-identical movements between people, allows people to have this self-other merging, as well as to connect with others socially from the same movements at the same time.
So next we just have an example to sort of show this. So one of the researchers did an experiment where they took a participant and sat him down and they hid the one participant's arm and replaced it with a rubber arm. So the rubber arm, strangely enough, was touched with a paintbrush and brushed back and forth as the arm behind the participant's back was brushed at the same time with a different paintbrush. So it was brushed at the same time as the hidden hand. And these synchronized strokes gave the illusion that the fake rubber hand that was being touched in front of the participant was actually the real hidden hand. And this effect also disappears when the synchronization is gone as well. So if the movements of the paintbrush were no longer aligning at the same time with the hidden hand and the rubber hand and the hidden real hand, that effect disappeared. So this is an example of self-other merging, and this is obviously, as illustrated by the rubber hand, it's eminent in both fake objects, inanimate objects, and human synchronized interactions, so from person to person.
So when we do have this social bonding and self-other merging, there are a number of different neurohormones and neurotransmitters as well as endorphins fired throughout this process. And so it's known as a cascading process, meaning that the neurohormonal firings happen one after another throughout the process of the activity. So really what happens, as I kind of mentioned before, with the EOS as well as some of the other neural hormones, oxytocin, vasopressin, dopamine, serotonin, and other endorphins are released by these EOS during the EOS system during social bondings. And so kind of as I said before, oxytocin really is this social neurohormone that's very, very prevalent in music, especially when we're participating in it with other people. Some other roles of the EOS helps a lot with pair bonding, especially in primates, as well as maternal care. Increased opioid levels are also associated with social grooming, as well as some affiliative behaviors in non-sexual or non-kinship relationships. So really the increased opioid levels help or alter your social perspective and the way that others view you.
Next we have a slide on endorphins in music. So music making, as Nathaniel has sort of talked about earlier, leads to oxytocin and endorphin release. So for example, singing, dancing, drumming leads to an increase in pain threshold, in mood, as well as the desire to exert effort further, compared to just passive music listening. So when you're actually in the act of making music or doing movements associated with music, you are more likely to have these increased benefits, whereas if you're just listening to music. Listening to music also helps manage preoperative hypertension and psychological stress, so this is good for post-op recoveries, pre-op preparations, and also in the PET and fMRI scans, there is an activation in the EOS system as well as the pleasure and reward centers in the brain. So specifically these opioid receptors that Nathaniel has been discussing, as well as other just regions in the brain that relate to pleasure, and this just sort of reveals the EOS's calming effect.
So really music kind of as an overall idea, as I said before, it provides a scaffolding for this social merging and synchronization to happen. So really, as the externalization of a synchronous movement music really helps facilitate those movements with one another. So there's this idea of dynamic attending theory that essentially when we monitor events that happen at temporal patterns, like let's say rhythm in music or something like that, we can be trained and we can be trained for those kind of events and the processes that happen from there. So which really shows that music is processed cross-modally, whether that be through our auditory systems, whether like linguistic systems as well, and specifically with movements. It really shows how music, movements, and emotions are all kind of interconnected. And so what's interesting is that music can cause the listener to either really consciously or unconsciously think about the movements that they're doing while partaking in this musical activity from motor region firing and that sort of thing.
Yeah, and we just have one wrap-up slide for you guys to sort of sum all of that up. It was a lot of information, but they use this chart to sort of just demonstrate how all of these factors are very much influenced by one another and how they really are all interconnected, and without one, the whole chart would fall apart. So there's association between music, social bonding, self-other bonding, as well as other neurohormonal mechanisms. And there was just one future question for research, which is, do these mechanism interactions occur in everyday settings rather than just in a lab with a rubber hand or in an experiment with a child and a drum? So, thank you.